Hello and welcome to the Daily Space for today, Monday, November 18th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. It is, as I just said, Monday. And this Monday is one of those Mondays where I looked at the news and I was just like, oh dear, that's a challenging topic. And so we're going to delve in to one of the most complicated things in astronomy on a Monday. And that thing is magnetic fields, and the application in this particular situation is the solar corona. Now, our sun is really confusing. It is at its surface just 6,000 degrees Kelvin. But then as you move away from it and get more and more distant, the temperature somehow rises up to over 1,000,000 Kelvin. And this is just confusing. And the paper I'm about to discuss that came out last week in Science is one that may not be the final answer on how it is that the corona gets so hot, but I think it's one that puts us on a solid trajectory to getting to that answer. And one of the things that it does is it starts to explain the formation of one of the structures that we've known about for a while. Back in the 1870s, we learned that the surface of the sun is covered in these features that we call spicula. And these small structures are essentially geysers of plasma. And when we measure them, we find them to be those millions of degrees that, well, is the temperature of the solar corona. And it's been thought that somehow the energy inside these spicula is able to get transported from the surface of the sun out to the corona. Not only that, but the spicula may also be the source of all the plasma we find carried away by the solar wind. So according to this paper that was led by Tanmoy Srinata and Hui Tiang of Peking University, the energy transport that we're seeing is rooted in magnetic fields. These spicula, the geyser-like structures that were discovered in 1877, these features form a forest of magnetized plasma. And in taking extraordinarily high-resolution images of these fields, what they found, what they found is the spiculas, according to the press release, and this is hard to understand, we're going to break it down afterwards. What they found is their observations argue that the dynamic interaction of magnetic fields with different polarities is responsible for the generation of many of the spiculas. So let's break that down. If you've ever played with magnets, you may have noticed that depending on how you orient the magnets, they will either attract or repel one another. This difference in how they behave is related to their polarities. Now, with the observations we're making of the sun, what they found is the emerging magnetic field lines come out in both polarities, and the spiculas tend to emerge where new features of one polarity are emerging in a region that had been dominated by the other polarity. So if you have a region of the sun that appears to be like the north magnetic pole of a magnet, well, if you suddenly have a new feature with the opposite pole coming out, around that particular feature, you will get these spiculas forming. And this process triggers reconnection of the magnetic field lines. This appears to be a gradual process, and this research describes it as a general progression of events that lead to the spicules. Weak magnetic fields appear frequently near existing large-scale networks of fields. So you have an area that is largely one polarity, you will see these field lines appearing near it. Occasionally, small-scale weak fields of polarity opposite that of the network, so these are the things that we're talking about, will grow outward and migrate toward the network, where they reconnect with the adjacent or overlying network field in the upper photosphere or low coronosphere. And this produces the spicules. So you have this region of one polarity, and then you get a region of the opposite polarity. So my fingers are the things, and their orientation is the polarity. And the formation of these over here causes the field lines to reconnect. I unfortunately can't just like float things in the air. So imagine they're reconnecting. And it's where this is occurring that the spiculas end up forming. Once the spiculars are in place, they are observed to have the temperatures that are comparable to the solar corona, and they eject the superheated plasma at speeds of 100 kilometers per second. That's fast. And this material, it looks like, is what's heating the corona. This research pushes what is possible with modern telescopes. From the mountains outside of Los Angeles, solar physicists used Big Bear Observatory here on the ground to take images every 3.5 seconds that could resolve 45-kilometer features on the sun. These ground-based observations were then coupled with solar dynamic orbiter observations of the corona's ultraviolet emission. Now, with all of this data, solar physicists are in a position where they can begin building computer models that will allow a coherent picture of the sun to be virtually assembled, one that traces energy from its point of generation in the core of the sun and follows it outwards to where it, well, eventually superheats the corona. So we actually have a video of this process. Let me see if I can get it to play. Let me see if I can find my mouse pointer first. There it is. Play. It did not play. Why did you not play? There we go. So here we are zooming in on Big Bear Observatory's images. This is the solar granulation, where essentially the surface of the sun is convecting like a lava lamp, where the core of that is rising hot material, and there is a spicula. So they really had to combine data from a lot of different instruments to do this. So here they're looking at the magnetic field properties and putting it all together. So this is only a start. More research is going to be needed, but a start is better than nothing. And this is definitely better than where we were last week. Observations are how we're going to build our way forward. So congratulations to the team from all over the world that worked to put together this paper that came out in Science last week. Now, from the complexities of solar physics, we're going to completely switch topics and look instead at the complexities of life. If you use social media or read science news online, you may have noticed several clickbaity titles lately where they're saying that NASA administrator says Mars 2020 could find life, and titles like Mars 2020 rover is going to go fossil hunting on Mars. Now, as someone who has used that exact title, fossil hunting on Mars, when giving talks, I can't slight folks for using that phrase, but I do think that care needs to be taken to not oversell what the Mars 2020 rover is trying to do. Hopefully launching sometime next year, this next U.S. rover will land on Mars in 2021 and explore Jezero crater. And this crater has an associated river delta. That's what you're looking at in this image. Whoops, I'm cutting my hand off. So that crater and river delta, it's hoped that this region will contain ancient organic molecules. And for the very hopeful among us, this region also has the same kind of geology, a carbonite rich layer that we know can preserve fossils here on Earth. Since this region clearly used to have water and has the kind of soil that can hold fossils, it's considered the best possible place to look for fossils. The catch is, we don't entirely know what we're looking for. It would be amazing if the rover could rove up to a wall of sedimentary layers and see fossil seashells and stromatolites and corals all clearly and indisputably visible. It's that second word, indisputable, that we need to worry about. There are those who fervently believe that the Viking missions in the 1970s found evidence of present-day life. But because the results weren't indisputable, and because extraordinary claims do require extraordinary evidence, it's generally said that life hasn't been found on Mars. Even here on Earth, there is debate around whether some of the stromatolite-looking formations in Australia are truly ancient bacterial mats, or if they could be the result of some other non-biological process. If the Mars 2020 rover does see things that kind of, sort of look like life, as formations in the Mars meteorite, Allen Hills 84001, look kind of, sort of like life, skeptics will be able to say, nope, nothing to see here, and will claim these are just plain old rocks. Making things even more complicated, fossilized life on Mars might look nothing like we can anticipate, and we may not be able to recognize these fossils at all. Basically, what I'm saying is Mars 2020 is going to a super cool place on Mars. It has all the potential in this world and that world to find fossilized life if there are such fossils to be found. But even if it does find fossilized life, I wouldn't expect NASA press releases announcing the discovery that don't use a whole lot of the word possible, and that, well, any such releases will offer alternative explanations of how such formations could have formed, and, well, extraordinary claims will require extraordinary evidence that this rover likely can't provide on its own. It's going to need a little help from a friend. Now, Mars 2020 is designed to be able to pick up samples that it can carry around, and it's planning to carry them away from where it picks them up to be loaded up for eventual return by a future mission. A future mission we're not building yet, but that might someday return these samples to Earth. And maybe in that future, when we have the samples on Earth, we'll be able to say, yes, that is a fossil of something that lived on Mars. And that's awesome. Now, while not making the same headlines as Mars 2020, the European Union's ExoMars, or Rosalind Franklin rover, has the same fossil finding potential. And its team are more quietly just as anxious to find life. Lots of folks really want life to be found, and they are trying to make the discovery process as straightforward as possible. This means going to the oldest land masses on Earth and poking them with scientific instruments to see if we can find evidence of our world's oldest life forms. The two oldest places on Earth are the Canadian Shield and Western Australia. And Australia has often proved itself to be a source of weird ancient fossils. In preparation for Mars 2020 and ExoMars, scientists from both teams have traveled to the Pilbara region of Western Australia to explore the fossilized signs of ancient life that exist there. Now, this isn't anything that I easily see as fossils. This is two hikers next to one of the cliff faces that allows you to see the kind of structures that they're looking at. And this is the pair of science teams trying to find those fossils. Now, these teams are working with fossil experts as they try to learn how to recognize stromatolites in ancient microbial life. To the untrained eye, my eye, the rocks in the Pabara region are just rocks. But to the trained eye, it's possible to see how life on Earth began so many billion years ago. By training their human eyes on what we can see on Earth, these Mars-focused scientists hope to be able to better understand what their rovers' robot eyes are seeing on the red planet. Assuming these missions make it past the Mars curse and are able to safely rove their 2 potential fossil beds, the next few years are likely to be rich in amazing headlines. And we plan to be here bringing you the science behind the clickbait, as life maybe is and life maybe isn't found elsewhere in our solar system. And that's all I've got for today. I will now take your questions, and while you type those in, I'm going to remind you, please precede your questions with a purple circle with a purple star inside of that circle. And while you type them in, I'm going to tell you this has been the Daily Space. My name is Dr. Pamela Gay, and this is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Each episode is produced by Susie Murph. And thank you so much. Thank you for the bits. Let me bring up the layer that would have allowed me to see who it was that just did that. And I have a very happy dog incoming. For those of you who don't know, when there are subs, when there are bits, when there are things like that, Eddie, up. Eddie gets treats. And we reward all of you with the cutest thing we've got, which is my dog. Oh, come on, Streamlabs. Reload. Reload. It doesn't want to reload. I'm trying to figure out who to thank. That was gross. Thank you so much. So many good things are happening. Thank you, Bad Panda, for 15 months of subscribing. Thank you, Trekker Kev, for the bits. Thank you. Hi, I see you. We are produced by Susie Murph, and it's really a whole team that puts these shows together. And Annie, our instro out there, helps us with all of our rocket episodes, and we are so grateful for the help we're getting from the Weekly Space Hangout crew in promoting this show. If you can't make a financial contribution, that's okay. Can you promote us to your friends? Can you leave us a review on iTunes? There's a podcast version of this episode. Get it wherever you find your podcasts. So we could use your help. Spread the word. You never know whose life you're going to improve by introducing them to science. All right. Okay. I'm now going to scroll and look for your questions. One final thing. I'm required to beg because that's my job. We currently have a funding drive going on for our servers. We use Amazon Web Hosting for all of our servers, and we are working to raise the funds to get a reserved set of instances for everything that we host across CosmoQuest. And by being able to get that reserved hosting, paying everything up front, it will drastically reduce our prices. So we're currently doing a fundraiser in the month of November to reserve the server instances in Amazon Web Hosting for 2020. Okay, now to your questions. Scrolling. Rigel asks, will the real Eddie please stand up? Yeah, he was totally zonked out of sleep when we started this episode. He's not into Mondays any more than us humans are. I actually, Binary Ablaze, managed to hide all the technology fails. Now, I'm not going to lie, there were technology fails. DogCam insisted on not working, so I had to restart Wirecast. But once I restarted, we were good. Thank you so much. I can't see what that is. Thank you so much for the host over One Girl, Two Beakers. Come on up. Ow. Hi. I need to trim your nails. Yes, I do. Yes, I do. Can I get a shout out to One Girl, Two Beakers? She does really smart shows, and it's worth checking out. Okay. I love the music reference, Broken Symmetry. My corona. Now I'm going to have an earworm, and I can't sing, so I'm not going to try to. I'm glad you were able to watch live, Ed. Yes, Raj Luthra. The corona is really hot at over 1,000,000 Kelvin, which makes it over 1,000,000 everything, really. Happy Monday, Veronica writes. Oh, you twisted, twisted person. Raj asks, have you seen the Parker Solar Probe data? No, I haven't yet. I need to catch up. I've been traveling for the past couple of weeks, and I know they just had a data release, but life is the thing that happens between podcasts. Is that the way it works? I don't know. I love the love affair between London Bee and Nightbot. Our Instro writes, my dog ate my homework. True story. There was one point when I was teaching a lab class at the University of Texas when I got a puppy, Leah, who some of you may have met. And Leah chewed up the corner of my students' homework and generally made a mess of it. And I had to be very apologetic. Yes, Roy Stang, this is live. I am using a teleprompter, though. I'm not going to lie. Yeah, so as Binary Blaze points out, we generally present the news, then I come back and answer all the questions. And the reason that we also have this format is we record things live here, but we also push it out on YouTube so that people who can't watch live during the day because they're at work or something, it happens, so that they can go back and watch it. And we just want to have that clean news experience to get the information out. And then we hang out and answer questions. So Paranor asks, so the magnetic fields make the spicula act like lightning generation on Earth? Sort of. Kind of. So lightning generation occurs when you have positive and negative particles frictionally, just like rubbing a balloon on your hair, get built up in clouds. And with this potential difference across the clouds, you can build up charge that will then jump from one place to another. And it's that jump of charge that we see as the lightning. And most lightning is actually cloud to cloud, but it's the cloud to ground that we notice the most. This is more the magnetic fields build up charge inside the circulating magnetic loops. And these magnetic loops, when they're not fully connected yet, can just geyser plasma. It's super complicated. I wish I could explain it better. We need more animations. We need more animations. I'm just going to play the animation for this in the background. There it is. Go back. Dog is moving my desk because this is what my dog does. Okay, nope. Play. I said play. There we go. All right, so let's see what other questions we have. So Rigel16 says, are we able to tell if other stars are hotter than they should be on the surface? And does this affect any measurements we make of other stars like size, luminosity, and other stats? No. So we can only see the sun's corona because the sun is so close to us. Uh, you may have seen it during the 2017 eclipse if you were in North America, or during one of the other eclipses that have been crossing the southern hemisphere in the past couple of years. The corona is that very thin, diffuse gas that surrounds the solar disk. Now, because it doesn't give off that much light, we can't really see the corona of other stars. And the bulk of the light that we get, the bulk of the photons that we get from any star, aren't coming from their version of the corona, so it doesn't really affect the measurements that we make. Larry comments, T-Rex bones on Mars? No, but that would be cool. That's not what we get, but it would be cool. Hello, Roria Rose. Yes, Hanny, we do need to cleave some Mars rocks in half, and they do have the ability to like burrow and take actual core samples now. So ExoMars and Mars 2020 both are a bit more robust. Now, as we've unfortunately learned from Mars Insight, we don't really understand the soils on Mars well enough yet, and digging on Mars appears to be a challenge. So it'll be interesting to see how those work. Oh, I love all of the dinosaur discussions. So Rigel goes on to ask, would an alien civilization incorrectly predict the size of planets in our solar system if they were using the transit method because of the unexpected heat our sun is producing? No. And like I said, we don't expect other stars to be any different from ours. They should all have these coronas that we don't understand. But because they're so faint, the other planets would see us transiting the main surface of the sun, just like we saw with Mercury's transit last Monday. So it won't affect anything noticeably. The corona is just super faint and something we can really only see because of where we are. But they should exist around every star. Looking to see what other questions we have. More comments about T-Rex poop. Yes, stromatolites are far more likely than T-Rex poop. Hi, one girl, two beakers. So out of order on the chat. So out of order. I read Arnstra's Guten Tag as gluten tag, and I was like, why are you tagging her with gluten? I may need reading glasses. Okay, so I caught up to the end of the episode. Hey, Susie. Yes, I have a floof, Perinar. Totally have a floof. Floof. Mike Cassidy says, maybe looking for life. Maybe looking for life would be a good citizen science project using our ability to see patterns. Yes, I don't know though if they'll have data coming in so fast that they can't handle it on their own. So the places that we want to use citizen science are the places where there's so much data that the science teams can't possibly deal with it on their own, where it's mutually beneficial, where you're enjoying it, getting pleasure, scientific curiosity sated out of the ability to be part of the team, and where we're not just giving you busy work. There was, for instance, a USGS announcement yesterday about how they got rid of a bunch of contractors and replaced them with children with autism who did the work for free. I have problems with that. On so many levels. So when we're looking for projects to do citizen science, we have to ask, is this something that can't be done any other way? And I don't know if we're hitting that first qualifier. I don't know if there's going to be that much data. I hope there's that much data, but I don't know. Um, yes, Eddie hears the bits ping and jumps up. This is entirely true. He is classically trained. Pavlov, eat your heart out. Um, so Broken Symmetry asks, what has Parker Solar Probe added to solar corona knowledge? I don't know yet. I need to go learn more. I will try and do that for tomorrow's episode. I'm sorry. Let's see. Eddie does make sure to get his good eyes. Good side, rather. Wow, can't speak today. I'd like to point out it's cold and I didn't come down here early enough to turn on the heating, so I'm slowly freezing to death, thus clutching my fingers here. Oh, Larry. Yes, brains do need cleaning after learning about magnetic fields. Thanks for the sub, Rosaria Rose. Thank you so much. I didn't hear a bing. I don't know why I didn't hear a bing. Come on up. Oh, hi, hi, hi. Yes, you heard a crumple. There you go. Such a good boy. Such a good boy. Funding. Oh, I see what you're talking about now. I put it up on my preview screen and I forgot to share it with you. I'm sorry. Yeah, I need to do something to change my screen layout. Sorry. Flail. I had it on preview. I forgot to change things. Sorry. Oh, you're just learning about hosting? It's not that hard. You'll get it. You may make mistakes. I clearly still make mistakes, but we're all human and we're just here sharing information. And it's a friendly group. We help each other. So welcome to the community. I'm going to switch over to actually showing the chat behind me. There we go. Ooh, she has a pet roach, referring to One Girl, Two Beakers. Why are you baby sharking Binary Ablaze? Do you not like us? Do you not like us? Scrolling. Yeah, our work happens. It's sad. So Paramore says, lightning to ground has a starting point from the ground as well as the potential difference in the cloud. Oh, that's true. You can get ground to sky lightning. I don't know enough about this. I know it's frictionally driven, though. This is why volcanic clouds have such amazing lightning storms. So I think the one is an electrical effect and the other is a magnetic effect as the dominant part of electromagnetism. I mean, both of them, because electromagnetism are so intimately locked together, both of them will have both electric and magnetic effects. But I think with the solar spicules, it's a magnetic effect that drives plasma, whereas with lightning, it's a plasma effect that has magnetic fields. So Hanny asks, could there be something like lightning on the sun? I have no idea. I just don't. Oh, One Girl, Two Beakers asks something I can answer. Yay. Can stars be different colors? Yes. They just need to be different temperatures. It turns out that the temperature of a star is dominated by the same things that make an incandescent bulb change colors as you turn up the amount of electricity going through it. So if you've ever had an incandescent bulb on a dimmer switch, When you just barely give it any electricity, it's a redder color and it becomes more yellow as you increase the electricity. And then it becomes what our eyes perceive as white as it gets hotter and hotter. Electrical stove burners have the same thing where they go from red to yellow. And if you could get them hot enough, they'd actually go to blue. So these differences in color are directly related to differences in what's called the black body temperature of the star. And yeah, Arnst is correct. It has nothing to do with chemistry. So Kerbal asks, when was the last time that Mars Science Laboratory did some drilling? Last I heard it had broken. I think it was drilling fairly recently. They did have a problem where they didn't know how to put pressure on it, but they did figure that out. I want to say I saw Emily Lactowala say something about it fairly recently. But there haven't been press releases about it, and there haven't been new papers about it lately. So I have to admit, I haven't been paying a ton of attention other than to what I sometimes see flying by on Twitter. Bad Panda. I like your comments about how Insight forgot their efficiency V pick. Yeah, Paranor also saw the USGS announcement. It was super annoying. Super annoying. So to those of you questioning how someone could not have a problem with basically replacing contractors with autistic children working for free, I understand how things like this end up happening. There's not a lot of money for science, and there's actually a legislative push through the American Innovation and something Act that calls for crowdsourcing and citizen science to be used wherever possible to reduce the costs of doing science. And it's been realized that there's lots of people out there who are extraordinarily detail-oriented and can do the same tasks that we as scientists often do. And there is an idea that by asking children to contribute to science in any means possible, that this will be positive for them. Now, the problem is, it's a very fine line between giving someone an actual science experience that is beneficial to them intellectually and giving them busy work that keeps them busy and benefits the scientists. And when you switch that who benefits, you have to ask, are you just using people? And here, I think they forgot to ask the question of who is getting the real benefit. And they simply looked at the cost savings and they looked at, hey, we have kids doing actual things for a science agency. And didn't go, but it's just busy work. Yeah. Arnstra says that he has to live in Daddy Longlegs. Does that count? Maybe. I don't know. Daddy Longlegs are fascinating, not quite spiders. Yeah, Hanny points out that oddly red is cool. This is one of the things about children's coloring books that really drive me crazy, because as small children are all trained that blue is cold and red is hot. And this is the opposite of reality. And I blame crayons and school teachers at the youngest levels who are not paying attention to black body science for why people are so confused by thermodynamics. Unintended consequences of coloring books. I am complaining, apparently, because it's Monday, about the unintended consequences of coloring books. So Mike says NASA's Curiosity rover is rolling and drilling again. Cool. And Binary Blaze is back. Yeah, Mike, scientists do need work. We do. We really do. We need funding. We have work. We're just not always funded to do our work. That's one of the things that we don't, it's like one of those untalked about realities of science is there's lots and lots of science that you run into where you have to write your grant proposals unpaid. So that's like unfunded labor. A good proposal takes about 2 weeks full-time effort to write. You have to write multiple proposals in hopes of getting one funded. So that's like weeks and weeks of unfunded labor that you have to do outside of your day-to-day work. You're often told you can't get funding until you do proof of concept. And if you can't get funding until you do proof of concept, you have to do the proof of concept for free. And then you're told, okay, we like your idea, but we're going to reduce your budget. But we're innovating new things, and it's already hard to stay on schedule when you're doing something no one has ever done before. And so you end up with always having unfunded labor. So yeah, science is unfunded labor in so many different ways. And citizen science is amazing, and I think it is the most honest part of it when it's done well. Because it is people doing things they want to do for passion and knowing up front that we're going to give them credit wherever we can for what they do. And that honesty of we will give you credit when we can, and we know you're volunteering, and here is what you're benefiting. That is honest. I think a lot of the hidden unfunded labor in science is problematic. So Larry asks, could solar plasma be considered pure lightning? I think lightning has very specific definitions of how it's a discharge between two different potential energies that solar plasma just doesn't fit. I love you guys in chat. I love you. Yeah, there's not a lot of sleep in writing grants. Okay, I missed something. Why didn't you sleep for 2 weeks, one girl, two beakers? Cause like that breaks human brains. I learned in graduate school I can go about 36 hours without sleep before I start hallucinating. And yeah, don't do that to yourselves. Okay, I'm now out of questions. I've hit the bottom of chat. And so Broken Symmetry says, any news on the grants you submitted? So far this year, I have been a co-investigator on 3 grants that other people did the primary writing of, and all 3 were rejected. One of them was rejected as excellent, but we don't think technology will let you do this yet. But we can't prove it unless we're funded to do it, and we think we can do it. And so we don't quite know what to do there. I submitted as principal investigator a grant October 1st that I haven't heard on. I have a transfer grant pending that is out of my control. It's waiting for another institution to provide paperwork that isn't getting provided. And then I submitted a 3rd grant on Friday. So the one I submitted October 1st, I could hear on any day or in 3 months from now. The one I submitted November 15th, I don't expect to hear about until February at the earliest. The one that I'm trying to transfer, I could hear about any day now or never. This is my life. We are going to be doing a hangout-a-thon to raise funding to cover all of our educational and streaming programs. We're going to be doing that the weekend before Christmas. I'm going to be doing all of our science efforts open source, where we're all volunteering until I get grant money. And even then, we're going to keep doing things open source. I'm just hoping that we can get the seed funding necessary to flesh out what we want to do and then focus on getting science funding to use that software. So this is my dream. This is where I'm trying to get. And we're getting there. It's just hard and it's slow. And I'm not going to lie, it's frustrating. I hate begging for money. Hey, we're raising money for our servers. I hate raising money. But thanks to you and thanks to my super efficient group of humans that I work with, Susie, Annie, we are able to do everything we do with the donations that you guys have provided in the past year. We've made it. We are making it. Our Osiris Rex funding that we do have right now ends December 31st. That's currently paying for our servers this year and has been funding citizen science development this year. So we're now thinking ahead to 2020, and we hope all of you will be there with us. All right. Hangoutathon.org. I don't know why. Yeah, NPR begs for money, and I give money to them. I am a sustaining contributor of my local NPR station. So Broken Symmetry asks, will I be able to donate with Google Pay during the Hangoutathon? I have no idea. I will try and figure that out. I don't know if anything we do that takes Google Pay, but I don't know why I can't set that up. So let me see what I can figure out. Okay. So Henny said, didn't you have funding end on December 31st last year? So that's not how it always works. So what happened last year is in the middle of October, in looking at what was happening to me and the rest of our CosmoQuest team, made the decision to quit my job and move to the Planetary Science Institute. I did that on a Tuesday afternoon, rather suddenly. Adopted a dog, that's Stella, and the folks at the Planetary Science Institute were going to talk to NASA about transferring my grant that Friday. Thursday night at 9:30 p.m. local, which means that it was really after hours in DC, my grant was officially canceled. And no one can officially tell me why. So we'd been previously told that there was a chance that James Webb Space Telescope overruns would lead to our cancellation. Politics, things, stuff. Whatever the truth is, we'll never know. But we went from having funding through 2020 to having funding that ended December 31st. And we raised money through last year's Hangoutathon to make sure that everyone was in our who was in our team was able to have some pay to bridge them through until they got a new job, or thanks to you, we've been able to keep going through this year. And unfortunately, the majority of grants are due in November. And since I didn't really start my new job until January, I couldn't get grants in on last year's November deadline. And it's been a trial this year. I have sold a lot of artwork to make ends meet, but our team is making it. And this is how we do things. We take care of each other. Raj Lutha asked, what was your project? We were funded to build CosmoQuest into a significant citizen science platform that anyone could join. And we were halfway through porting our software to a new platform when we got canceled. So we got canceled at the absolute worst possible moment because we hadn't been maintaining our old code base, but our new code base was not ready to be used yet. So it's been a fun year. Yeah. I'm glad you like my paintings, Kerpel. I think we need an average of 75. A 75 what? Oh, no, we haven't made partner. We do need an average of 75 viewers. And our daily space averages 40 something viewers, but we do a lot of other streams that are random one-offs that have anywhere from 12 to 100 viewers. And there's 12s kill us, and there's hundreds are very few and far in between. So our ongoing average viewership has only been in the 20s, and we're not going to make partner in the 20s. But this is our reality. But we're still here, and that's kind of awesome. And I'm slowly freezing to death while I'm still here because I didn't turn on the space heater because I was only going to be down here for half an hour, and I've been down here for over an hour, and I'm cold. I'm cold, people. Like actually clenching my hands cold. So tonight we will be simulcasting at 8 p.m. Eastern. That's 5 a.m. Pacific. Open Space, which is hosted by Fraser Kane, our good collaborator over at Universe Today. So stay tuned to watch that. And there is a major NASA announcement of some sort this afternoon. I don't know what. So we'll see what that is. And as always, thanks for being here. We are brought to you by you. But more than that, we are a product of the Planetary Science Institute, working to explore our solar system and beyond. We are produced by Susie Murph, and it takes an entire team to do everything that you see here. And I have to say so many thanks to our mods, to Paranor for simulcasting for us, to our Instro for helping us with our Rocket Wednesdays, to Susie for helping host when necessary, and Annie for being my regular co-host. We're a team, and we're a team with you. And thank you for being here to collaborate with us as our backers, our cheerleaders, our supporters, and our grassroots marketing. So we will be back tomorrow. We are brought to you most Mondays through Fridays at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. So wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.